Strange things have been happening in the nearby solar system. It's only a 4 light-year journey to the star system Proxima Centauri, and astronomers have been picking up on some strange signals emanating from one of its planets for quite some time. Artificial lights have disturbed some of the sharpest brains in space. But what exactly are they? Is this evidence for the existence of intelligent entities on Earth? Is there another advanced society in our immediate vicinity? Stay tuned for additional information on the James Webb Telescope's discovery of artificial lights on Proxima B. Let's begin with an overview of the topic. The light that remains on our planet when it is dark is the most obvious indication that life continues to exist here. The lights of Earth's major cities can be seen shining brightly into the night sky. The issue is that contemporary telescopes do not have the sensitivity necessary to pick up photons coming from very far away solar systems. However, there are a significant number of researchers who are already evaluating the possibilities of the telescopes of the next generation that have been envisioned. Taking a look in your direction, James Webb, if there are any takeaways, what exactly are they? It is feasible for us to discern whether or not Proxima Centauri harbors any other forms of intelligent life, depending on how technologically or luminescently advanced their civilization is. In light of new studies on technosignatures, there is now a greater chance of determining whether or not the light on Proxima B is caused by artificial sources. Based on what we know, not only is this planet located in an area where life can exist, but its mass appears to be comparable to that of Earth. The fact that it orbits the nearest star is by far the most crucial reason why we should be able to learn a great deal more about it with modern technology, particularly with the James Webb Space Telescope. Next, signs of alien technology. Another key topic of the new research is the LUVUA, or Huge UV Optical IR Surveyor, which is a multi-wavelength space-based observatory that could launch as early as 2035. The authors, Stanford's Elisa Tabor and Harvard's Ava Lope, argue that a technological civilization cannot exist without artificial illumination, which is especially true on a planet with a perpetually dark night side. The chances of two civilizations emerging in the same location at the same time are so remote that this is one of the longest of long shots. However, the artifacts that a new civilization leaves behind on the world that it chooses to explore may provide information about its origins and culture. There are a few markers that can be used to determine whether or not an alien culture has left a technological footprint on a faraway world. We could theoretically detect events like the dimming of a distant world's light, which you already know happens on Earth if we had a large enough constellation of satellites. The greater the number of satellites we launch into orbit, the more likely it is that the pollution of the atmosphere caused by nuclear war will be apparent. Orbital debris or a comet attack could produce these technological warnings. Starlight is not the same as artificial light. Last year, the aforementioned Elisa Tabor and Ava Lope undertook an online search for alien lights. Following, Proxima B. However, due to the fact that it is still in the process of being developed, the results were not entirely accurate. The JWST will focus its attention on Proxima B, the only planet that is currently known to exist in the Proxima Centauri system, which is located around 425 light-years from Earth. The rocky planet known as Proxima B is located in the habitable zone of the M-type red dwarf star known as Proxima Centauri. Just 12% of the total mass of our star. The size of Proxima B is comparable to that of Earth, and its radius is also about the same. In just 11.5 days, it travels 7 million kilometers, which is approximately 5% of the distance between the Sun and Earth. According to the Tabor and Loeb scale, the amount of artificial light that is required to complete one orbit around Proxima Centauri is equivalent to a fraction of the solar illumination that our planet's day side reflects. On this scale, a value of 100% indicates that the night side of the planet is completely dark. A score of 100% would indicate that both the day and night sides of the globe have the same amount of brightness, which is clearly not the case. Because light-emitting diodes, LEDs, are a common form of artificial illumination here on Earth, it is reasonable to anticipate that inhabitants of Proxima B will employ a technology that is analogous. So, what do we currently understand? Additionally, the light from Proxima Centauri. The site distinguished artificial light with an 85% success rate. Webb's detection rate would climb to 95% when the artificial night-side illumination of Proxima B reached 5% of the natural day-side illumination, and to 97% when the artificial night-side illumination reached 9% of the natural day-side illumination. It doesn't seem like much light to have only 5% of it. What you're thinking is correct, and I know why. Putting a firefly next to stadium lights is an excellent analogy for contrasting the brightness of the light light from Proxima Centauri to that of the Sun, which is roughly 20 times dimmer. But even on a cosmic scale, that much light is a lot. In comparison, artificial light on Earth accounts for 0% of the stellar illumination reflected back to us. That is, if a Proxima B civilization were as brightly lighted as ours, a web search would provide no results. That lighting will have to be 500 times brighter. It's possible. Because Proxima B's orbit is so close to that of its host star, it is likely that the planet is tidally locked, with one side of the planet always facing the star and the other enduring permanent night. A civilization on a tidally locked world would have to invest a lot of effort into refining its lighting system, and our telescopes would be able to detect it if it utilized exceptionally strong orbiting mirrors to bounce sunlight onto the day side of the planet. Next, telescopes spotting the glow of an extraterrestrial civilization. Of course, this is just speculation. According to Tabor and Loeb's findings, future telescopes such as LUVOIR or the Massive UV Optical Infrared Surveyor may be far better than the JWST at detecting the light of an alien civilization. That data was submitted just a few days after the researchers' publication by Thomas Beatty of the University of Tuscany's Department of Astronomy. Beatty investigated the LUVOIR and HABIT or Habitable Exoplanet observatories to learn how they will detect the brilliant lights of cities on planets orbiting stars 30 parsecs away. The distance between two PCs is around 326 light years. Both the HABEX and LUVOIR spacecraft are expected to launch in 2035, and they will catalog and directly scan exoplanets in a variety of star systems, including those containing known planets like Proxima B and possible Earth-like planets circling GK and NC-class and N-class stars. However, there is still a long way to go before these missions are successful. BT simulated the observations of LUBER and HAVOC. BT also scaled an urbanized area of the planet's surface. More cities mean a brighter night side of the Earth. The artificial illumination in this model is based on high-pressure sodium streetlights, which can be distinguished from starlight due to their spectrum properties when reflected off of concrete surfaces. These bulbs power the great majority of the world's lights. As a result, the virtual scopes scan planets in order to gather enough light coming through the void to determine the target, and the variables are the planet's distance from Earth, its degree of urbanization, and the sort of star it circles. To put it another way, urbanization has only reached about 5% of the planet's geographical surface. A telescope from Proxima Centauri would not reveal Earth to an observer looking in. Finally, what is Ecumenopoulos? We might have a greater understanding of a civilization that is many light years away if there were, say, twice as many people living in cities as there are now. However, what does it imply if everyone resides in a city? The name Ecumenopoulos comes from the Greek word for universe. One definition of a city-planet describes it as a world that is predominantly occupied by a single enormous metropolis. I am aware of what you are thinking. It does appear to be fantastical. The best part is that there are multiple examples, such as the planet type Ecumenopoulos in the galactic strategy video game Stellaris, or Coruscant, which is the capital of the Republic Empire in Star Wars. Other examples include. On the other hand, it's not completely out of the question that a highly advanced society will one day cover the entirety of the planet in a sprawling metropolis that never stops growing. It's hard for me to wrap my head around how open and honest that world would be. According to forecasts made by BT, in the not-too-distant future, observatories will be able to find ECU monopoly worlds in orbit around 82 sun-like stars. Well, that marks the end of today's video. Hope you enjoyed it. Remember to like, subscribe, and leave a comment down below. Thanks for watching.